So for this example, SMH and Sons purchases 8 sets of furniture with list price of $3,200 each. The trade discount is 11/8/3. The invoice is dated 7/27 and the terms are 310 EOM. The seller prepaid $600 in freight. SMH pays $12,000 on 9/9. Calculate the balance remaining on the invoice. Well, there's a process to go through here. First thing we should do is probably create the invoice. So on the invoice, come here. What's the date of the invoice going to be? It's dated 7/27. What's the amount? You had the right effective date. The amount of the invoice. That's going to take a little bit of work yet. The list price will be $3,200 times 8, which is going to be $25,600, right? But then we need to find, after the trade discount, we need to find the net price. We have an 11/8/3 trade discount. So that would be 0.99 times 0.89. 100 minus 11 is 89, so 0.89. 100 minus 8 is 92, so 0.92. And 100 minus 3 is 97, so 0.97. I multiply that out. I get 0.794236. I will then multiply the 25/6, the list price, times that net price ratio rate. So times 25600. 2332.44. $20,332.44 is the amount on the invoice. We have terms on the invoice. 310 EOM. And there was freight of $600. And we are looking at a $12,000 payment on 9/9. So we have constructed the invoice here. Let's do the timeline. Where does this timeline start? Yeah, it's going to be 8/31. Why 8/31? End of month. Why not 7/31? It is after the 25th. It goes into the next month. It does not make it into July's batch. It has to go into August's batch. So it is 8/31. So then this here, the end of the discount period will be 9/10. In that period, they get a 3% discount. And of course, the very end will be 9/30. So they have the payment made on 9/9, which is right here, which means they get 3% discount. So what's the first thing I have to do with that $12,000 payment? I have to pay the freight. So 12,000 minus 600 is $11,400 after freight. That's what goes to the invoice. So now what do we do with that $11,400 to get the amount of credit? There's one more thing we have to do first. Divide by the complement of the discount. Yes. So 11,400 divided by 0.97 is 11,752.58. That is the amount credited to the account. So then to find the balance, we take the invoice amount, which was $2332.44, and we are going to subtract the credited amount, which is 11,752.58, which is going to give us $8,579.86 is the balance on the invoice after the payment. How many of you had that right? How many of you had everything down before or knew everything you need to do before I said it? Okay. Just a matter of time? You need more time? Well, let's do one more example before we dive into our new stuff. FMA Limited purchases $19,000 in inventory on 7/2 with a trade discount of 812. The terms are 515 net 30 ROG. Delivery is confirmed 8/3. Seller prepays $900 in freight. Find the balance. After a $9,000 payment on 8/17. I'll give you a few minutes to try that. Let's get back there. So let's create our invoice. What's the date of our invoice? Oops, that's not it. Told you I had to be careful. Our original date of the invoice will be 7/2. The effective date will be 8/3. The amount that's going to appear on the invoice is going to deal with the 812, 0.92 times 0.88, which is going to be 0.8096. I'm going to take that 0.8096 times the list price of 19,000 to get $15,382.40. What else has to go on an invoice? Terms, which are 515 net 30 ROG. Two other things we have to note. Freight is $900, and we also have to note delivery on 8/3. And yes, we are asking about $9,000 payment on 8/17. So our timeline starts on what date? 8/3. This is going to end on 8/18, 15 days. That's 5% discount in that period. And of course, this is going to end on 9/2, but that's not important. It was paid on 8/17, snuck it in under the wire. So what do we do with our $9,000? Subtract 900 for freight. So 8,100 is what's going to get applied to the invoice. What do we have to do with that? Not multiplied. Divide. Gives us 85.2632. That is the amount that gets credited to the invoice. So that means we take our invoice amount of $15,382.40. That's the amount from the invoice. And we are going to subtract the credit of $8,526.32. So you get $6,856.08. How many of you had that? How many would love to have a quiz with these on them? I had to try. Is there anybody that's totally buffaloed yet? Sure. Oops, come on. Yeah, for those. Okay, so hopefully everybody's caught up there. So last week, we were talking about going from the wholesaler supplier to a retailer. This week, we're taking the next part of that chain, going from the retailer to the consumer. The price comes into the retailer. They pay, or the merchandise comes into the retailer. They pay a certain price for it. That is called the cost. The retailer turns around and sells it to the consumer at a certain price. That is called the selling price. Those two are obviously not the same. The difference between them is called the dollar markup. Notice I put in there a little plus sign. The general formula that governs this section is cost plus markup equals selling price. The markup is listed as a percent. of either the cost or of the selling price. So the first question is, why would you want to do it one way or another? Well, doing the markup based on cost is easiest for just setting prices. Because when you buy it, you know what it costs you, right? So it comes in here, you know the cost, you find a percentage of that cost, you add it on, it gets you the selling price. But using a percentage of the selling price is easiest for bookkeeping. Because what you can do, if you know that your markup, that you're sometimes referred to as a margin, is a certain percentage of what things sell for, all you have to do is at the end of the month, you look at your cash register totals and you can calculate a percentage and get a good estimate of what your total markup was for that period of time. So both of those are important. So we're going to start out talking about markup based on cost. When we're dealing with markup based on cost, the base of our calculation is the cost. In parentheses, I'm going to put 100%. Remember, whatever we're basing, since we're dealing with percents here, whatever we base our calculation on is 100%. So let's look at some examples. For an item that costs $70, markup is 30% of cost. Markup is 30% of cost is basically saying it's a 30% markup on cost. Find the dollar markup. I'm going to start abbreviating markup as MU, by the way. And the selling price. For cost and selling price, when we ask for cost or selling price, we're always implying that it's a dollar amount. For markup, we have to specify whether it's a percent markup, the 30% is the percent markup on cost, or if it's the dollar markup. Well, this is a percent problem, and it's a percent increase problem. So there's really nothing new here over what we saw in week 3 when we did percents. We can use our little table. We have cost plus markup equals selling price. Percents on one side and dollars on the other. We have $70 cost. We have a 30% markup. So here's markup. The 30 is on the percent side. It appears as though that's all we have. But of course, we always have 100%. Since this is markup on cost, it's 30% of cost, it implies the 100% goes to the cost. So now, along with that, then we can very quickly figure out selling price is 130%. 100 plus 30 is 130%. Now I can find either one of these over here just as simple. Let's do the dollar markup first because that's what we asked for first. When I'm doing that, I don't need the bottom row. So I will cross multiply and divide. 30 times 70 divided by 100 is $21. So the dollar markup is $21. Now back to finding this selling price. Two ways I could go about it. Of course, I could just do 70 plus 21 is $91. Or if I wanted to go through it more the long way, to be sure, to double check, if I'm looking for that, I wouldn't need this row. So I'd cross multiply 130 times 70 divided by 100, which is 91. So there's two ways I can figure it out. I always figure it out with the cross multiply and divide, and then I double check by adding to make sure they add up. Let's look at some more examples. Let's say we have a product whose cost is $190. The markup is 60% of cost. Find the selling price. Cost plus markup equals selling price. In this table, I'm just going to go right through the information I have. Where's the 190 go? Cost, the dollar side of the cost. Where does the 60 go? Percent side of the markup. What else do I know? 100% goes on the cost, which tells me this is 160%. What am I trying to find? The dollar amount of the selling price, which means I don't need that row. What am I going to multiply here? Perfect. 190 times 160 divided by 100. $304. Any questions? Yeah, well, we'll get to some problems where that isn't going to work. You're just multiplying by 1.6? Yeah. Let's say that we have an item that has a cost of $150. It has a selling price of $210. Find the percent markup on cost. So we have cost plus markup equals selling price. Percents and dollars. Where's the 150 go? Cost, which side? Dollar side, you got it. Where's the 210 go? Selling price, the dollar side. What do we have that isn't written? It's on cost, so the 100% goes with the cost. There's one thing we can very quickly calculate here, and that is the dollar amount of the markup. How would we find it? Yeah, 210 minus 150. Subtract, right? Those two have to add up to the 210. You just subtract. Now we are looking for the percent markup. So we're looking for this. So we don't need the bottom row. Now what can we multiply here? 60 times 100, then divide by the 150, which will be 40. So that is 40%. Let's say your cost is $75. Your selling price is $105. Find the dollar markup. I'm going to give you a second to think about this one. I'm going to make the table here just because. Really didn't need to, though. Cost $75, markup's $105. We're looking for the dollar markup. All we have to do is subtract. That's $30. Any questions? Okay. Pretty easy so far? No. We have an item that's selling price is $280. The markup is 40% on cost. Find the dollar markup. Here's where doing that decimal kind of starts to give you some difficulties. So yeah, cost plus markup equals selling price. What do we know? Let's start at the top. 280 goes dollar amount of the selling price. 40 goes percentage of the markup. Where does 100 go? It goes on cost. We can figure out that the selling price percent is 140. We are looking for dollar amount of the markup. We will multiply 40 times 280 divided by 140, which should be $80. Had you tried to find 40% there, the problem would have been is the 40% of what? The thing that the 40% is based on would be the dollar amount of the cost, and we don't have that number. So that becomes a problem. So we're going to have you guys try a few. Our selling price is $450. Our markup is 25% of cost. Find the cost. I'm going to give you a minute to find that. Okay, so 450 goes selling price. 25% markup. 100 on the cost. So that makes this 125, and we are looking for the cost. So we don't need the middle row. 100 times 450 divided by 125 is going to be what? 360, right? Any questions there? We have a cost of $210. We have a selling price, $294. Find the percent markup on cost. I'll give you a minute there again. 210 goes. There we go. 294 goes. 100 goes. Percent cost. We can quickly calculate. 294 minus 210 is $84 is the dollar markup. And then, okay, we are looking for that amount. So yes, we don't need the bottom. Yes, 100 times 84 or 84 times 100 divided by 210 is 40. That's a 40% markup on cost. You still got it right? That helps. That works. You could have done subtracted this, and you could have used like 140 here, and then subtracted the 100 from it. Is that what you did? Okay. So you didn't bother subtracting at all. You just went straight off and got the 140. That does work. It's like I said before, there isn't just one right way to do math. There's several other methods that will work as long as you're consistent with them. Okay. Actually, not going to do that. I'm going to do a selling price of $336. Markup, $56. Find percent markup on cost. I'll give you a minute. Where's the 336 go? Dollar amount of selling price, yes. What's next? $56 goes in the dollar amount of the markup. 100 goes in the percentage of cost. Perfect. We subtract here to get $280 here. And we're looking for percentage of the markup. Cross multiply and divide, we get 20%. Come on. There we go. Let's say our cost is $350. Our markup $30 of selling price. Find the dollar markup. I'm going to give you a minute. So where's the 350 go? Dollar amount of cost. The 30. Markup percent. The 100. Why did I put it there? It's now 30% on selling price. What that is saying, this is now cost based on selling price, or markup based on selling price. I kind of set you up there. In cost based on selling price, we have the markup, or cost markup based on selling price. The markup is a percent of the selling price. So the selling price is now the base, and 100% is going to go with the selling price. It's time for our break, so when we come back from break, we will talk and do some examples on markup based on selling price. So we just mentioned this markup based on selling price. And in our example here, we saw that the 100% had to go with the selling price. So let's finish off this example here. What does that mean going backwards here to the percent representing the cost? You would subtract going backwards. 100 minus 30 is 70%. Now looking for the dollar markup then would be this number here. We actually do not need that bottom number. So this is one time where we're not even going to use the number that represents the 100%. We will do 30 times 350 divided by 7 is 150 bucks. So normally we would use markup based on selling price. What's that? Yeah, go back up. Sure. There you go. Did it work? Okay. So normally we would use this markup based on selling price when we're given the selling price. Let's say our selling price is $60. A lot of times when you evaluate merchandise, you look at it and you realize, I can put that in my store, but this is what I can charge. This is what my customers would be willing to pay for it. 60 bucks. I have to have a markup of 20% of the selling price. So we can find the cost. In other words, what can I afford? What's the most I can afford to pay for this? And still keep my 20% markup on selling price. So cost plus markup equals selling price. 60 goes dollar amount of selling price. 20% goes percentage of markup. Where does the 100 go? Selling price percent. Which means we can calculate very quickly. 100 minus 20 is 80% for the percent that represents the cost. And we are looking for the cost. So we're going to ignore that middle row. 80 times 60 divided by 100 is $48. So let's say we have a selling price of $120. Our markup, 25% on selling price. I want you to find the dollar markup. I'll give you a minute to find that. So let's put this together. 120 goes dollar amount of selling price. Very good. 25 goes percentage of markup. 100 goes. Percentage of selling price. We are looking for dollar markup. We could very easily find the 75% here, but we have no need to. My eraser ain't working. We have no need to because we're not going to use the top row. This is what we're looking for. 25 times 150 divided by 100. $30 is the dollar markup. So the selling price is going to be $250. The markup, 25% on cost. Find the cost. I'll give you a minute. Where's the 250 go? Dollar amount selling price. 25 markup percent. And of course the 100 goes. Yeah, you caught that. On cost. The 100% has to go with the cost. So then we can very quickly find that this is 125%. We're looking for the cost. Cross multiply and divide. 200 bucks. I tried to sneak this problem in here. You caught me. Just to show the importance of being very, very careful. Just one or two little words makes the difference between where you put that 100%, whether it goes with the cost or whether it goes with the selling price. You put it in the wrong spot and you are out of luck. On this second unit test, which is coming up next class, and next class, I mean 2 weeks from tonight, because next week there is no class. That is the single question that's missed the most, is when we switch from markup based on cost to markup based on selling price, people forget to move that. So we have a markup of $90. We have a cost of $360. Find percent markup on selling price. I'll give you a minute. 90 goes. Dollar amount of markup. $360. Dollar amount of cost. What else do we need here? 100% on selling price. We can very quickly find the dollar amount of the selling price. It's adding as we're moving down. We add 360 plus 90 is 450. We are looking for the percent markup. So that's what we're looking for. So I'm going to ignore that top row. 100 times 90 divided by 450 is 20. Any questions there? So the markup is 40% of selling price. The markup is $28. Find cost. I'll give you a minute. 40% goes percent of markup. 28 goes dollar amount of markup. What else? 100% on the selling price. We're going to subtract to get 60 for the markup. 100 minus 40 is 60. And we are, or 60 for the cost, I should say. And we are looking for the dollar amount of the cost. So 60 times 28 divided by 4 is $42. Any questions? So let's say that our cost is $35. Or sorry, $350. Cost is $350, sorry. Our selling price is $420. Find percent markup on selling price. Where's the 350 go? Cost. Dollar cost. Where's the 420 go? What else do we have to put in there? 100 goes on selling price. We can very quickly find dollar amount of markup, just 420 minus 350, $70, and we are looking for the percentage markup. 100 times 7 divided by 42, which is 16.67%. Remember, fractions and decimals are now our friends. Yes. $16 2/3 is technically the exact answer, but in my math lab, they would tell you to round to the 10th of a percent or whatever. Yeah, 16.67 would be fine there. 16.67%. There, is that better? We're all art critics tonight, apparently. So we have a cost of $480, a selling price of $600. Find percent markup on cost. So where's the 480 go? 480 goes on dollar cost, 600. Dollar selling price. What else we got? 100% on the cost percent. Yes. We can very quickly calculate. 600 minus 40 is $120, dollar markup. We're looking for the percent markup on cost. So we are going to ignore this and we're going to cross multiply. 100 times 120 divided by 480 is 25. 25%. I'm using exactly the same numbers, except I've changed what? Find the percent markup on the selling price this time. I'll give you a minute to find it. 480 goes. I'm going to cost. 600 goes. I'm going to selling price. 100 goes. Selling price this time. 120 is found by subtracting. This time, however, we're going to use the bottom part of the chart. 100 times 120 divided by 600 is 20%. Now you'll notice here the numbers were exactly the same between these two problems, but it came out to be a different percent. Because this one was percent on cost and this one is percent on selling price. First of all, will it be true that the percent on cost will always be larger than the percent on selling price? Well, if the cost and the selling price are the same, yes, because if that markup is the same, the cost is smaller than the selling price, always, hopefully, right? We'll look at some markdown situations where they might take a loss. But if the dollar markup is the same, the cost would be smaller than the selling price. So the markup will always be a larger percent of the cost than it is of the selling price. So what if we want to convert between cost or markup on cost and markup on selling price? So let's look at a situation here. Where we are going to have a cost of $225, a selling price of $300. We're going to find the percent markup on cost. $225 is the dollar cost. $300 is the dollar selling price. 100 goes on the percent cost. We subtract here to get a $75 markup. Now I want to pause. Any questions on where that $75 comes from? Just 300 minus 225. And we're looking for the percent here. So what are we going to multiply? Perfect. 100 times 75, and then divide by the 225 is 33 1/3%. Now, I'm putting the same numbers up over here, but this time I want to find the percent markup on selling price. I'm just going to leave it right in this chart here. And I'm just going to put a column over here. This was on cost. But a column over here is going to be on selling price percent. And what's going to change is the 100 goes with the selling price. But I'm still looking for this amount. This time, what numbers am I going to multiply? Yeah, 100 times 75 and then divided by the 300, which is going to be 25%. Make sure everybody has time to get that one down. So if our cost is $200, our markup is 25% on the selling price. Find the selling price. Cost plus markup equals selling price. We're going to put, come on, $200 in the cost, dollar cost. 25% is the markup percent. 100 goes selling price. We will subtract here to get the cost of 75%. We are looking for the dollar amount of the selling price here. So what are we going to multiply? Yeah, 100 times 200 divided by 75, which is going to be what? $266.67. Based on that same information, $200 cost, $266.67 selling price. So that's a markup of $66.67. Find the percent markup based on cost. So the 100 would go in the cost, and we would end up multiplying 100 times 66.67 divided by 200 is 33.33%, 33 1/3. Notice something here. When we did markup based on selling price, it was 25%. Markup based on cost with the same dollar amounts, it was 33 1/3. Up here, when we did markup based on selling price, it was 25%. We kept the same dollar amounts. The markup based on cost was 33 1/3. Whenever the markup based on cost is 33 1/3%, the markup based on selling price will be 25%. Doesn't matter what the dollar amounts are. Those percents are linked together. So we can actually convert a markup based on cost to a markup based on selling price, or the other way around, without knowing any of the dollar amounts. So let's look at convert a 40% markup on cost to an equivalent markup on selling price. My chart's going to look a little one-sided here. Really doesn't matter which one I put where, but one of these is going to be percent on cost. The other one's going to be percent on selling price. And before I do anything else, I can put in 100s here. In this first column, where's the 100 going to go? Yeah, the cost. Second column, where's the 100 going to go? Selling price on bottom. What's the only other number we know here? 40%. Which column is that going to go in? Percent on cost. So this is the one on cost, right? Now we can very quickly add those up to get 140% would be the percent of the selling price. We want to convert that to an equivalent percent markup on selling price. which is that number right there. Guess what? 40 times 100 is 4,000. Divided by 140 is 28.5714286 approximately. So we'll go 28.6%. What do you think? No? Oh, come on. Convert a 20% markup on selling price to an equivalent markup on cost. I'm going to give you a couple minutes, see if you can handle this. So what do we put in here? Now I put percent on cost first and percent on selling price second. If you change the order, it really doesn't matter. Where's the 20 going to go? Under the selling price is the percent markup. There's some 100s I can put in here. It goes here for the selling price column. Their cost for the cost column. I can very quickly calculate here what number? 80. 100 minus 20 is 80% is the cost in the percent on selling price column. Of course, I'm looking for this. I'm going to ignore that. It is 100 times 20 divided by 80 is 25. 25% markup on cost. What do you think? Perfect. I was just trying to decide, should I do one more or move on? So. Convert a 50% markup on selling price to an equivalent, I'm just going to say to a markup on cost. If you can get this far, we've got the chart set up like this with the 100s in the correct spot, you have 90% of the battle won already. What else do we put in here now? Markup on selling price is the 50%. That goes there. 100 minus 50 makes this 50. And of course, we're looking for that. So we'll ignore this. 100 times 50 divided by 50? 100. That's a 100% markup on cost. A 100% markup on cost, by the way, just means you take the cost and you double it, and that's your selling price. What's that? Yeah, that's a really, some of your clothing is done that way a lot. Electronics is often marked up more than that. The product, by the way, anybody know the products on the market that have the lowest markup usually? Food. Food is actually regulated. Gas actually, yeah, it depends on how you calculate the gas markup. That's a tricky one. Groceries are actually regulated with a minimum markup. If you ever go to Walmart, they have their price match guarantee. They actually had to put signs up on any store that's near a state border because each state has different minimum markup laws. We cannot match the prices for Minnesota because Minnesota has a slightly lower minimum markup on groceries. Can of Campbell's soup that costs like what, $1 might actually cost them 93 cents. They might only be making 7 cents on that. Very low profit margin on groceries. The iPad for $300 probably has less than $40 worth of parts. $40 worth of materials, I should say, in it. Yeah. Furniture has an incredible markup. Markdowns. There are a lot of reasons for markdowns. You might have products that are out of season. Most people know this trick. Anybody with kids is definitely knows this one. Best time to buy a winter coat is not right now. March or April is the best time, if you can still find them on the shelf. The problem with it is stores stop ordering them in about January and they get depleted. So you might get something really ugly if you buy it in March or April. There are issues with it as well. A lot of stores will stop buying like winter boots and winter coats, usually early December. So if something happens and you like destroy your winter boots or lose your winter coat or winter boots, often in January it can be tough to find a selection of them. Because, yeah, that never happens with kids. Of course, now it happens more now. I can remember if I'd have came home from school, if I had lost my winter coat, I would not have come home from school, put it that way. But that's a whole different story. Another reason for markdowns is close to expiration. If there's any sort of perishable to it, you see this all the time in the meat department. Reduced for quick sale. That means it's really old and about to spoil. We want to get it out of here quick. Let it spoil in your fridge instead of our cooler. That's usually what I go for too, because if I buy meat, it usually is cooked that night. Also, change in trends. I'm not a big fashion person, so I'm not going to come up with a great example here, but yeah, bell bottoms were trendy again a few years ago, and now they're going out. So the only thing I could think of was the MC Hammer pants. Those were hot. I mean, people were paying like $70 or $80 a pair for those in the 90s. All of a sudden, I'm sure they will. So normal price of an item is $40. It is marked down 30%. There are several ways we could look at this. One would be to do a chart just like we did before. Full price minus our markdown equals sale price. We could do that, but markdowns, it's usually simplest to use a complement. Remember what that complement was? We're dealing with percents. The complement was 100% minus that discount percent, which gives us 70%. Remember we did this for our net price ratio for the chain discounts? 70% as a decimal is 0.7. So we're just going to take our $40 times 0.7, get a new price of $28. Not so bad. So normal price or full price is $90. It's marked down 20%. Find the sale price for me. So to find this is going to be $90 times what? 0.8. So $72. You could do times the 0.20 and get $18 and then subtract it. Yeah, that works. Get 72. But you guys know me well enough to know that if there's something like that, I'm going to FOIL it. The sale price is $18 after a 40% markdown. Find the full price. Well, this is very similar to our partial payments on their invoices. Up here, we had the full price. We multiplied by the complement to get the sale price. Here, we're going to have the full price times what would the complement be? 60. 100 minus 40 would be 60%. So 0.60, which would give us the sale price of $18. If we want to work backwards here, yeah, if we consider this basically our variable of X, we divide by 0.60. That full price is $30. Let's look at a winter coat or oat, one of the two. Original price of $80. Goes out of season. Hits that March deadline. %30 markdown. Still there next fall. Well, guess what? They're going to mark it back up. Why not? The next spring, it's still there. %30 marked down, 35% marked down. 2 more months, they decide just plain ugly. %45 marked down. Find the new price. Oh, there is. We have, get back, come on, there it is. An $80 original price. 30% markdown. What's the complement of that? 0.7. Now, this is the tricky part. A 40% markup is a 1.4, right? 100 plus 40%, it's a markup. Whole plus another 40%. 35% markdown will be 0.65. 100 minus 35 is 65. 0.65. 45% markdown? 0.55. We can take our 80 bucks times 0.7 times 1.4 times 0.65 times 0.55. And that's our price, $28.03. It's time for our break. Let's take 10 minutes and we'll be back to talk about perishable. So we have an object with a regular price of $120 on the 7th of October. It has a 30% markdown. On March 18th, has a 25% markup. And in September 30th, has a 40% markdown. Find the final price. I'll give you a minute to do it. So we're going to start out with the 120. What are we going to multiply that by? 0.7 for the 30% markdown times 1.25 for the markup times 0.6 for the markdown, which will give us, what is it? $63. So 120 times 0.7 times 1.25, because it's a 25% markup. It's 100 plus the 25%. Then times the 0.6. Let's look at spoilage. Spoilage alert. I like that. That's okay. Spoilage can be one of two things. It can actually be perishable goods, or it can be trendy goods. So perishable is usually food. Trend would often be clothing, goes out of style or whatever, goes out of season, however you want to put it. When we are dealing with either one of these, we cannot price things, we cannot work individually anymore. We have to work on what's called a lot. Of course, a lot is not like many, a lot is a group of material, a lot of items. So let's look at an example. Sam's Bakery. Makes 400 cookies at a cost of 20 cents each. Sam expects 10% to break or spoil without being sold. Can't sell a broken cookie, right? Sam requires, Sam needs, however you want to put it, an 80% markup on cost. How much should Sam charge per cookie? The reason we have to look at a group of items rather than each individual is some of the individual items aren't going to sell. So what we have to look at is the price of that whole group has to be set in such a way that we're going to, one, recover the cost. Now it's going to be total cost. And the required markup to get a total selling price. So we're going to add some steps to our process here. Step one, find the total cost. What's the cost per cookie here? How many cookies? 400. That's $80 cost. That is the total cost. Step two is going to look awfully familiar. Do the markup. We do the markup on total cost now, though. So this is total cost. Back up. This way? Okay. Total cost plus the markup is going to give us total selling price. We found our total cost to be $80. Our markup that we needed was 80% on cost. That's important, right? So 80% goes here for the percent markup. 100 goes for the cost, right? 80% on cost. So that means on bottom is going to be 180. We need to find the total markup, or total selling price, I should say. So we are going to do 180 times 80 divided by 100, $144 is the total required selling price. Step three is the spoilage factor. What percent did we expect to go bad without being sold? 10%. Come on now, there we go. 10% spoil, what percent is good then? 90% are good. Where'd the 90% come from? 100 minus 10, very good. We have 400 cookies, of which we expect only 90% to sell. So 400 times now 90%, remember I'm putting in 0.9, right? 360 will sell. So the last step is to find the individual selling price. And I'll move this up in just a second for you. The individual selling price is found. I have to take the total selling price of the $144 and divide by the number that are going to sell, the 360. So what we have here, come on, that's the total selling price. This is the number that are going to sell. What's that come out to be? 0.40. So they would need to charge 40 cents a cookie to get their price, their money back out, and plus their profit. Not so bad. Pat's Pizza makes 150 pizzas at cost of $4 each. Actually, let's make this an easy one. 8% will spoil without being sold. Pat needs a 120% markup on cost. How much should be charged per pizza? You guys talk me through it here. What do I need to do first? So I need to find my total cost. And that is, I'll stick my pen to the screen here. There we go. Yeah, $4 each times 150 pizzas is $600. Step 2, markup. So we have cost plus markup equals selling price. Now this is total cost, total selling price. We have, of course, the 600 here is the dollar amount for the cost. Yep. We need 120% markup on cost. So since it's a markup on cost, you notice I've already put the 100 in on the cost percent. The 120 goes in for the markup percent. I can add those up to get 220% is the selling price. Cross multiply and divide. 220 times 600 divided by 100. $1,320. That's the total required selling price. What's next? Spoilage. What was our percent spoilage? 8% spoilage, which means 92% sell. So we are going to take how many pizzas? 150 times 92 is 138. 138 pizzas sell. Next, find the individual selling price. We do that by $13.20 divided by the 138. $9.569.57. Right. What do you think? Better than sharp stick in the eye? Better than last week? This week's a lot easier than last week's. So, Kim's Creations bakes cupcakes. Kim bakes 500 cupcakes at a cost of 35 cents each. Kim expects 20% to be damaged or spoiled. Without being sold. Kim needs a 70% markup on cost. And because I'm getting tired, find the selling price. I'm going to give you guys a couple minutes to try this in your notes. So we start out, total cost. How do we find it? 35 cents times 500. What's that? $175. Perfect. We mark it up. Cost plus markup equals selling price. I'm not going to write the words total in there, but you guys understand this is total cost and total markup. So we have the 175 in there as the total cost. We have 70% markup on cost. So that's 70% markup. The cost is the 100%. Making this 170. Looking for this number, we will multiply 297 point what? 0.50, okay. So 170 times 175 divided by 100 is $297.50. Is our total selling price. And then spoilage. Okay, 20% spoil. So that means, yeah, 0.8 or 80% are sold. So 500 times that gives us 400 sold. And then get the individual selling price, $297.50 divided by 400, which is 74 cents. Any questions? Okay. Pat's Pastries. Pat's Pastry. Oops. Pat needs to stay there. Pat's Pastry bakes 400 donuts at a cost of 45 cents each. Pat expects from experience 15% to go unsold. Now, before I say more, some of you might be thinking these percentages seem kind of high, 15%, but you got to understand, especially in a bakery, the cookies, donuts, whatever, they're selling them fresh. They've got to bake them guessing at what's going to be sold. They don't want to have them sold out early in the day and not have any more to sell and people come in wanting them. Because two things happen. One, you miss out on the sale, and two, people come in enough and they're not there, they're going to go somewhere else looking for them and stop coming in. So you're going to bake extra, counting on some of them are not going to sell that day. So Pat expects 15% to go unsold. Pat needs a 90% markup on cost. Unsold donuts will be sold for 10 cents each as day old. So it's very common. They don't sell that day, so they put them on the back cooler or cabinet or whatever, and they mark them down. The next day they're sold as day old. Or they might get sold for bear bait at a discounted price or whatever. This is going to change step 3 a little bit, perishable. But step 1 is exactly the same. Total cost. 400 donuts times 45 cents. 180 bucks. Total cost. Step 2 is unchanged. Find the markup. That total cost of 180 bucks goes in there for the cost. 90% markup on cost. So 100 goes in the cost. 190 is the selling price. So 190 times 180 divided by 100 is 342. $342 is our total selling price. Now to the fun part. Spoilage. Make it look a little bit less like a 3-year-old writing in crayon. What percent is going to spoil? 15% spoil. What percent are sold? 85% sold. There are 400 donuts. 400 times 15% is 60 that spoil. 400 times 0.85% is 340 that are sold. Before we move on to step 4, we've got to deal with these 60 that don't sell. Because what's going to happen to them? Sold at 10 cents each. Now, you might say, well, that's just extra profit. But We're going to be exact here. We've got to account for it. 60 donuts times 10 cents each is $6 from the spoiled product. What that means is we have to adjust the total selling price. We need $342. We're going to get $6 back out of the spoiled ones. We only need $336 for the ones that sell. So now on our selling price here, instead of $342, we're going to use $336 divided by the 340 that sell, which is going to give us 99 cents each. What do you think? I think you guys should try one example of this before we go. Stacy's, what's Stacy going to make? Stacy's pies? Okay. Stacy's pies bakes 50 pies at a cost of $2.50 each. 10% spoil. Stacy needs 140% markup on cost. Spoiled pies are sold at $2 each. Find that selling price. Got you stuck. So first step, total cost. How do we find the total cost? $2.50 each times 50 pies is $125 total cost. So I'm going to pause. Any questions on how I got the total cost? Okay. Next, we need to mark up. Cost plus markup equals selling price. We've got this there. $125 goes on the dollar side for cost. What goes in for our percent? 140, right? 100% on the cost. So 240 is our selling price. So we will cross multiply and divide here. 240 times 125 divided by 100 is $300. $300 total selling price. What's next? Spoilage. What percent spoil? 10% spoil. Let me make that look like the word spoil a little bit. 90% sell. Yeah, 50 times 10% is 5 that spoil. 50 times 90% is 45 that sell. Five spoiled times $2 each is $10. $300 total selling price minus $10 equals $290. So what this was $300 total selling price, minus the $10 from the spoiled ones. Gives us $290 that we need to get from the sold ones. Yes, 290 divided by 45 is 6.44. There isn't a quiz due tomorrow. That is Thursday at 11:59 p.m. And a new homework that I think is actually still due for next Tuesday. Even though there's no class next Tuesday, you still get the 1 week on the homework. I will see you again 2 weeks from tonight for Unit 2 test. You can come in early that day if you want to, yes. I'm here at 7:30 in the morning in this room. The only exception would be from 10:30 to 12:30 now on Wednesdays. I'm going to be teaching a class for Nicolay College. So it'll be on the network, so the door will probably be locked for that 2-hour period. That'll be the only exception.